So welcome back. I hope you enjoyed the plenary. So our first speaker now of the session is Dr. Annemarie van der Marel from the Pontifical Catholic University of Italy. So she will talk about the key role individuals play in driving social instability. So Annemarie, you can now, you are sharing your screen and you can talk. Thanks a lot.
Oh, thank you so much for attending. I'm showing here some preliminary results of my postdoctoral work in collaboration with Lauren Hayes and Louis Ebelsberger. So often social groups are composed of members with diverse, partitioned and stable social behavior that are based on either different individual attributes or behavioral traits. And then group composition can affect group dynamics and functioning. For example, house sparrows, in house sparrows, social groups can mediate physiological stress when the group is composed of individuals with different personalities. In guppies, foraging success was higher in groups composed of different personalities. And in degus, groups with more females experience greater direct fitness. And certain group members may have a disproportionately large effect on group dynamics and are centrally connected. These are considered to be key individuals. And these key individuals may affect group function. And here's how it may play out in the group. For example, in bottlenose dolphins, they function as brokers connecting different subpopulations. In macaques, key individuals function as policers because they maintain social order. And in elephant and killer whale populations, key individuals may be essential for foraging due to the ecological knowledge they carry. So potentially, these key individuals are the glue that hold societies together. So when you kind of think about animal societies, we can have species where social groups are more socially stable, with low fission fusion dynamics, low turnover rates, and really few group membership changes. But on the other side of the spectrum, you have species with much higher levels of social instability due to higher fission fusion dynamics or higher turnover rates. So that means with way more group composition changes. Often higher levels of social instability could reduce cooperation or reproductive success. So in the animal kingdom, different mechanisms have evolved to kind of like maintain stability. One is conflict management, as it's seen in many primates, or cooperative foraging, as seen in these vampire bats. But as well, the group composition and the kin structure could maintain stability, where species, for example, associate preferentially with certain group members, or where the presence of key individuals help maintain stability. So I got interested in understanding what kind of role, whether there are key individuals and what role they play in driving social instability or stability in degus. So degus are social semaphore rodents that are endemic to central Chile. So the blue star in the map is our field site just outside of the capital, Santiago. They show a variable and unstable social organization with low kin structure, and they have cooperation in the form of communal care and social foraging. And they're kind of like an outlier among rodents because they have low reproductive output, high mortality, and limited indirect benefits. So when I talk about instability in the degus, I don't mean really on a short-term basis. It's more on a longer term. So we talk about social instability in degus when we talk about changes in group composition between seasons. So the group composition in the fall is often different from the group composition in the spring. And in the fall, that coincides with the mating season. Then the degu, the females have like a 3-month gestation period, which is very long for such tiny animals. And in the spring coincides with juvenile emergence and communal care of the juveniles. And in degus, higher levels of social instability reduces often alloparental care or reproductive success in the form of weaned offspring quality. So when we talk about social groups, we kind of consider them as the nighttime burrow sharing associations. So we kind of get at these burrow sharing associations by using telemetry. So this is just an example of the fall telemetry in last year's field season. So we look at it for 20 nights per season on a degus subset in the field site. Then we combine that data with observations and trapping at the burrow system early in the morning when they just come out of the burrows to obtain group membership. This resulted in 19 social groups in 2023 with an average group size of 3.4 animals, with more females than males in general. So to identify key individuals, I decided to use a multiplex centrality metric. So because social life is complex and multi-layer network approaches, where each interaction type represents a different layer of the social network, has the potential to better capture this complexity than single layer approaches. And I also decided to use the multi-layer border count because this allows to use different centrality metrics on each single network layer, because each layer might represent or convey different information in the group. So we used for the proximity network, I used between the centrality for the kind of means like which individuals are important for information transfer. For the affiliative interactions, I used their vector centrality, so which individuals are influential across the whole network. And for the agonistic interactions, I looked at degree centrality, so who are the most highly connected individuals. So then you can, for this is just a fall season, and then you can kind of get a graph like this, where ID is on the x-axis and the border score on the y-axis. And the individuals with lower border score are then considered the key individuals. So we used this kind of like this cutoff, and there's like kind of like 9 individuals in this population that are considered to be key. And there's also a very highly skewed distribution, with few individuals that are key and most individuals are not centrally connected. So then can we kind of like find out what characteristics these key individuals have? So who are these key individuals? So individuals with a central network position may be males, as they may be important for information transfer. Or they might have larger anogenital distances, and that is a proxy for masculinization that occurs through prenatal exposure to androgens. And in degus, this masculinization level affects reproductive success and aggression. So we performed GLMMs to obtain observed coefficients, and because of the network data, we performed node swap permutations. Then we ran 1,000 permutations and then compared observed to the randomized distribution. So what you kind of get is then this histogram, which the gray histogram represents the reference distribution. Then the blue dashed lines, the 95% quartile, and a confidence interval. And then the red line is the observed coefficient. So if that falls within the blue dashed lines, that factor probably doesn't have an effect on who is key. But if it falls outside, it probably does have an effect. So what we found is here actually on the y-axis, you see a border rank instead of border score, just to make it a little easier to show, and where the key individuals are ranked 1 to 9. So the key individuals are more likely to be males. And for both sexes, like males have larger anogenital distances than females, but for both sexes, you find that more centrally connected individuals have larger anogenital distances. So we kind of now know who these key individuals are, but what function do these individuals play within their social groups? So if key individuals drive social stability, then we expect groups with key individuals to have higher cohesion levels. And we looked at that by looking at the diameter, which is the longest of the shortest paths in the network. So we did not find that diameter was different among social groups with key individuals or social groups without key individuals. Then we could also expect groups within key individuals to have increased connectivity. And we looked at it through density, which is the ratio of links present in all potential links of a network, and the average path length, which is the average of the shortest path between all pairs of the nodes in the network. But again, we did not find any differences among groups with or without key individuals. So we also expect the groups with key individuals to have decreased aggression. So overall, we find that within groups, there are very low levels of aggression compared to between groups. And we did not find that our prediction was supported because we did not see a difference between aggression among groups with or without. But when we look at aggression between groups, we find that groups with key individuals are actually more aggressive to members from other groups. And kind of in a similar sense, we expect the groups with key individuals to have increased affiliation within the group. Again, we found lower levels of affiliation within the group compared to between groups. But again, our prediction was not supported because actually we found that groups without key individuals are more affiliative to one another. And groups with key individuals are more affiliative to members from other groups. So until this far, it doesn't seem that key individuals influence within group dynamics. But we only have looked at these network metrics, and we haven't looked yet at kind of like the output of these social groups by looking at reproductive success or survival. So, and for this, I'm waiting for the genetic analysis to be finished, which should be at the end of this year. And key individuals seem to influence the entire network instead of group functioning alone. And this, like, remember when I said that I defined the social groups as individuals sharing a sleeping burrow? So that means that what happens at night might not really convey what is happening during the day, because then when they come up, they can actually like start exploring the field site and interact with other individuals. So these key individuals might be more important for the entire network instead of just their social groups. So then overall, what is in the function in driving social instability across seasons? So in DEGUS, the cost and benefits are not shared equally among group members. So for females, it is beneficial to have more females in the group or with greater membership stability, because it results in greater communal care. For males, it also is beneficial to have more females in the group, and but with lower membership stability, because it allows for breeding opportunities. So because males are more likely to be key and instability is actually beneficial to these males, then we, instead of like thinking that these key individuals are the glue that holds societies together, maybe in the DEGU, they actually drive social instability and these groups composition changes across seasons. So there's a lot going on in this slide, but so this is a Sankey diagram of like the group composition changes across seasons. So on the left, we have the fall group composition. On the right, the spring group. Each burrow is considered to be a social group. And each line represents an individual DEGU, and the ones in purple are the key individuals. So when we talk about a stable social group, there are no membership changes across seasons. When we talk about an unstable social group, there are membership changes due to death or emigration or immigration, and they only consider adults here. So kind of like to make a little bit of sense out of this mess, I summarized this. Overall, there are really few groups that remain stable. There were only 2, and those were both without a key individual, but the majority of the social groups are unstable. However, for this, I've actually used also like when individuals are removed. So, but then we don't know whether it's actually due death or dispersal. So they might like, have just disappeared because a fox ate them. So we don't, so to kind of like get more at this question, like, are there actually group composition changes, or is it just like a demographic process? So, this was, so first, like these preliminary results, it doesn't seem that they impact social instability. But when we just look at groups with composition changes based on addition only, we get a little bit of a different result. However, it's still not really clear that key individuals drive social instability. There are still, because there are more groups that are considered stable, but about the similar amount of groups that are unstable when they have key individuals and when they are without a key individual. So it is still, there's not a clear relationship with being a key individual and social instability. However, this was just based on one field season. So I'm just wrapping up the 2024 field season. So please stay tuned on these results. So overall, during this, for this research, we've defined that DEGUs do have key individuals, and that key individuals are males and have larger energy and total distances. It doesn't seem that key individuals affect any group level network metrics, because it doesn't affect cohesion, connectivity, or aggression, or affiliation really in their social groups within the season. And these social groups are based on the sleeping burrow associations. But now I'm kind of more interested in seeing what the effect is on the entire network. And what is the function across seasons? Again, there's no clear relationship with being a key individual and social instability in the case of the DEGUs. And with that, I would like to thank my collaborators and the field assistants and my funding sources. Thank you.
Thanks, Annemarie, for this super talk. So we have already one question. Thank you for the talk. The question is from Catherine. I was wondering if old individuals are more likely to be individuals, or is it independent of age?
So the DEGUs, they don't really live long. Actually, this year we have a couple of individuals that are actually old. They're like 4 years old, but that is actually an exception. Most day groups really do not survive after their first breeding season. So we don't really use age in this question because there's just the majority is the same age.
Thanks. We have another question from AB. Talk, can you explain a bit more about the role of K individuals? You show that presence of K individuals lead to a greater between group agonistic and affiliative interactions. Are these groups generally more active and hence show more interactions, or and then there is another question. You can answer this one.
Can you kind of cut out a little bit?
I can get back.
Yeah.
Can you explain a bit more about the role of K individuals? You show that presence of K individuals led to greater between group agonistic and affiliative interactions, but are these groups generally more active and hence more interactions?
So I do have to kind of look more into those kind of details, but what I did find is that these groups with key individuals have like greater aggression and affiliation to members from other group members. But then I don't know whether that's the more aggression or more affiliation is just really done by the key individual, or if it is like done by all the group members. Maybe it is also kind of like that all the group members are more explorative and actually kind of leave their own territory and interact with their the entire network instead of just their group members. So I cannot exactly answer that, but I'm still working on those analyses.
And there is another question for AB. If you look at the activity level of these K individuals?
No, we have not looked at the activity level. It might be, so I was interested also to see in the exploration, and then I would like kind of look at their home range size, like the core area, and also just like the larger home range, to kind of find out whether they also have like, it just like are more active around the whole field site and not just really in their own, around their own burrow system. And that is also something that is still in the analysis pipeline.
That's perfect. I have a question for you. So when you measure the stability in the group, what is the time scale? Maybe the stability can vary with the season. So maybe the group is more stable before breeding, for example, or after breeding. What is the time scale you used?
So for this presentation, I've used actually kind of like a big time scale because I just wanted to have that many interactions. But I used the fall season as almost from really the beginning of mating until well into the gestation period of the female. So it's actually kind of like definitely 2 months, not 2-month period. However, because the mating season is definitely different from when the females are gestating, and the males are just like, you suddenly have new males in the field site, then the next day they're gone again because they're just searching for females in estrus. So that definitely might have an effect on group stability. And I do find that there's a big difference between the group stability between the fall season and the spring season. In the fall, it's definitely like the whole entire network is almost connected. In spring, definitely not. There's like very distinct social groups individuals really stick with their own group members.
We have another comment from AB. It will be very cool if you find that the presence of K individuals influence the group behavior.
Mm-hmm.
And I have another question for you. So at the very beginning of your presentation, you showed the Borda scores, and it gave you like one very high K individual and other like 8 K individuals, but with a smaller score. Did you try to look at the influence of this one separate from the other 8 one? Like maybe this one has more power in the group or something like this?
I have to look at that. I have not done that, but that would definitely be interesting. Yes.
Maybe this one has more like power to influence the other, and it would be nice.
And I think it also depends a little bit on the centrality metrics I've used, because if one individual is has a very high score in one network metric, in the one network, it might kind of like overpower the other networks. So he might be, that individual might also be just very centrally connected in one of the networks only. So I have to double check that. Yeah.
So thank you for your presentation, and it's now the end of the question time. So you can now leave the session, and thank you again for your presentation.
No, thank you so much.
On Discord for your other questions.
Yeah, thank you. Bye-bye.
Bye.